wake up. Last three presentation. Some people ask in this conference, what are you doing? What I studied? This is the answers. The title is Evaluation of Japanese Eel. Eel. And the japonica freshwater fish habitat in Japan, Kyushu areas, using eDNA analysis. Only one speech in this conference. So there are three topics. One is why we choose eel. Second one is a methodology of environmental DNA. And final result is to show a map. And what should we do? I want to evaluate these areas. So why we choose eel? Because their eel need two ecosystems. One is, of course, ocean side, yeah, estuary. One is terrestrial areas. So that's important. Both is important. I want to do the reconnection, the ecological services, the mountain mountain region, terrestrial region, and offshore region. We have symbolic society. For only one Japanese is here. So, do you know where is here? Do you have an answer? Do you have an answer? Japanese. Do you know? Where is here? You see, this is the wood print picture made in 1930 to 44. Please focus on here. Capturing Japanese eel. Please remember 1830, 1844. The now situation is like this. We're saying this is Tokyo Sky Tree, central area of Tokyo. Just 180 years time flow is just one way. Nobody can change again. It's a situation of habitat. But anyway, in Japanese, Anguilla japonica, it have habit in some areas. And I show you one more the picture. I like this picture, very like, because this picture was written in our target areas. You see, this is Anguilla species in Japan. Of course, today I introduce Japanese eel and giant mottled Anguilla marmorata. European eel or Philippine mottled eel is already eel-based. This is doubtful. You see, endemic species is this one, and this one, and maybe this one. This European eel is coming from maybe black market. So objective 3, how should we restore suitable habitat for the Japanese eel? So we are monitoring using eDNA and habitat assessment. Finally, so this is a plan. I want to make a plan. And next step is do and check the action. This is our objectives. So the study is here. I want to meet him in the one more Japanese, Tahira-san. Do you remember the Tahira-san? Very young Japanese, come here. Because his hometown is here. But no. But here, this is Kyushu region, western part of Japan, and this is the migrate course of Japanese eel. Spawning site is here. Mariana areas are coming across the crucial current over 5,000 and going back again. First, hit it here. So this area is very important for their stock or as a habitat. Expand here. Yep, that's it. So this area, the point Each colored point is monitoring point or the sampling for the environmental DNA. The color is showing the places. This is the inner bay, Omura Bay areas. This is the offshore zone. And this is tidal flood areas. And it's most important is this one, dike. Dike are exist already. Completed in 1997. You see, this is inside of the dike. This is outside, and we're focusing on the boundary area. Please remember this color and boundary areas. And this is a picture. It's very useful for dike. The length is 7 kilometers. So huge. So only perfectly block the ocean side and inside areas. The picture like map is like this. You see, this is outside. This is dike. No, sorry. This is outside, inside, and dike. I wanted focusing on boundary area because the dike was perfectly stopped the migration of Japanese eel. You see, like this. This is dike, outside or inside, and boundary areas. We check the environmental data like this from this region. This is a methodology of environmental DNA. This is definition. Freely together identify organisms using the base sequences of gene constraint in samples, river, water, etc. and herbicide. Of course, all the organisms has a gene, has a nucleated DNA, have the structure ADCT, ADCT, ATGC, or etc. Of course, we have the same. eDNA is first we have to detect from the water filter, and finally we check base. The order is important. If order is same, very easy to understand. This is the same. If order is different like this is different species. We check through the database. So we call this either base sequences. This is one very simple method of environmental DNA, how to identify species. Yes, this is a methodology. In the procedure, there are two methods. One method is, if you want to know all the species in the river, you have to check everything. This is a more standard way. And this time, we wanted to focus only Japanese eels. So we procedure was done, quantified eDNA concentration only for Anguilla japonica. Yes. This is the young collaborators. Yes, they are checking. Yes, they are detecting the water for 300 millimeter. You see, 300 millimeter is only. Yes, this is from here is the result is identify species by field biological survey. Biological survey. You see, this is almost all the species endangered, endemic, but this one is maybe introduced one. Yes, another is the native. You see, like this, field work is like this. Field biological survey, but almost all the people look for the holiday. Next one. You see, this is result two. The size of the circle showing the eDNA concentration. Copy per 1 liter. Copy means the number of DNA fragmentation. Fragmented DNA number divided 1 liters. You see. The life cycle means the high potential of eel. Please remember these colors. Because I want to show you this. This is a vertical line showing the eDNA concentration I for all. The horizontal line showing the location. So basically, we want to compare inside and outside. You see, inside and outside, the value is quite different. So it shows the potential as a eel habitat. This time, we focusing on the boundary area. It's almost same to outside. You see, almost same. So we check again. You see, this is outside or inside. If we can make a pitch path or something, we can support. We can make again the migration path like this. This point and this point and this point is we detect Anguilla japonica DNA. This is first time we found out sampling the syringe like this. This is point here. So this is a solution for plan. What should we do from now? You see, this is outside. So many eel are there. This is now. So I want to make a path just like this. It seems waterfront park like this. This I drew map myself, and we're spreading. Now the stage is just like a pie in the sky. In English is pie in the sky. I teach you the Japanese. Japanese is rice cake of paper. Rice cake of paper. That's a Japanese word. Of course, pie in the sky. But anyway, this is final one. Okay, summary. Just a minute. Oh, sorry, 3 minutes. Okay. Japanese monitoring using eDNA data is very sensitive and effective. For example, we use GIS, very easy to make a map, compare, and find out this one proof. This one is same, but this is almost impossible to read. Second one is they are showing the map. Then finally is plan, in the sky. And next one, I want you to. So thank you very much. So we are trying. Thank you very much. So we are challenging with